In this video, the topic is representing integers on the number line. Now, we have 0 at the center point. All the positive integers are represented on the right side of 0. All the negative integers are represented on the left side of 0. And you can also observe there are two arrows on both the ends of the number line, which suggest that the number line extends in both the directions endlessly. So we have many numbers on the right side and we have many numbers on the left side as well. There is no greatest positive integer. There is no smallest negative integer. Fine. Now why are we saying that? Because we have always learned, when we learned about the number line with whole numbers, we have learned that the positive numbers were represented like this, and we can already see that the number on the right, any number, is greater than the numbers on the left. So if we talk about plus 3, it is greater than 0, plus 1 and plus 2. So now if minus 1 is an integer that is on the left side of plus 3, so plus 3 is also greater than minus 1 also. Now the second point that comes to our mind is, see, now this is the starting point. If you observe here, all the positive integers have been represented by yellow blocks. All the negative integers have been represented by the white blocks, just to differentiate. But 0 is represented by another color, a different color, that's red. Why? Because 0 is neither positive nor negative. So if we move to the right of 0, then we get positive. If we move to the left of 0, we get the negative numbers. Now, so one step towards the right gives us plus 1. So definitely when we move one step towards the left, it gives us the opposite of plus 1, which is minus 1. So these are a few points that we will revise with this video, the concepts of representing integers on the number line. So the first point that we revised was that any number is greater than the other numbers which are to its left on the number line. So if we compare minus 1 and minus 3, we'll observe that minus 1 is greater than minus 3 because it is to the right of minus 3. And next comes the topic of absolute values. Next comes the topic of absolute value. So we have the definition of absolute value here. The absolute value of an integer is the distance of that integer from 0 on the number line. So absolute value of plus 2 will be 2 because it is at a distance of 2 units from the number line. Similarly, if we talk about absolute value of minus 3, it is 3 units because it is at a distance of 3 units on the from 0 on the number line. Now that does not matter whether it is on the left or it is on the right, because we are only concerned about the distance of that integer from 0 on the number line. Now we have always noticed that distance is always positive. So the absolute value of an integer will also be positive. Anytime the absolute value, whenever we say the absolute value of an integer, so whether the integer is positive or it is negative, the absolute value will be positive. Now this is the symbol for absolute value. So when we apply it on 4, we get the answer 4. When we apply it on minus 3, we get the answer 3. When we apply it on 0, we get the answer 0. So that was the concept of absolute value with the presentation of the numbers on the number line. That whenever we talk about the absolute value of a number, so if we talk about the absolute value of 4, we are looking at the distance of 4 from 0 on the number line, which is 4 units. Now if we look at the absolute value of minus 2, it is 2 units. So the absolute value of minus 2 is 2 because it is at a distance of 2 units from the number line, from 0 on the number line. 0 is neither positive nor negative, so its absolute value remains the same. And now we have another concept. When we were saying that increasing order, when we were saying that the numbers increase when we move towards the right, so if we talk about all the negative numbers, what can we say about the greatest negative number? Now there is no negative number on the right of minus 1, so therefore the greatest negative number is minus 1, and there is no smallest negative number because we have an arrow here. We can subtract 1 and we can reach to another negative number over there. Similarly, when we talk about the positive numbers, we don't have any greatest positive number because the number line extends indefinitely towards the right. But we have the smallest positive integer, which is plus 1. Next, we come to the concept of additive inverse. Now, the additive inverse of an integer is defined as the negative of that integer. The additive inverse of an integer, the negative of an integer, is called the additive inverse of that number. Okay, so you can observe here plus 1. So the negative of plus 1 is what? Minus 1. So they are additive inverse of each other. Plus 2, minus 2, they are additive inverse of each other. Plus 3, minus 3, they are additive inverse of each other. So we have again given two examples here. 4 is the additive inverse of minus 4. Minus 100 is the additive inverse of 100. So the negative of the number. So the negative of a positive number is negative. The negative of a negative number is positive. And if you observe here, you'll also observe one more thing, that when we talked about the absolute values, an integer and its additive inverse have the same absolute values. So let us look at the absolute value of plus 2. It is equal to 2 because it is at a distance of 2 units from 0 on the number line. Now, what is the additive inverse of 2? Additive inverse of 2 is minus 2. And now if we see minus 2, what is its distance from 0 on the number line? It's 1 and 2. So it's 2 units. That means the absolute value of minus 2 is also 2. So that's a very important concept related to integers, that an integer and its additive inverse have the same absolute values. So in this video, we have learnt about the representation of integers on the number line, 0, all the positive numbers on the right, all the negative numbers on the left. Then we learnt about the concept of absolute value, and we learnt about the concept of additive inverse of an integer. Thank you.